Understanding static versus instance members in Java. Hello everyone. Welcome to this comprehensive guide on a fundamental concept in Java programming, static versus instance members. In this session, we'll demystify these two crucial types of class members, helping you write more efficient and robust Java code. Why this concept matters. Foundation of Java. Java programs fundamentally rely on the interaction between objects and classes. Understanding how members behave within this structure is key to effective programming. Individual data needs. Some data, like a student's name or a bank account balance, needs to be unique to each specific object created from a class. Shared data needs. Conversely, certain data, such as a university's name or a global interest rate, should be common and accessible to all objects of a class, without needing multiple copies. Efficiency and clarity. Static versus building. Instance members provide the architectural tools to manage these distinct data requirements efficiently, leading to optimized memory usage and cleaner code. Instance members, what are they? Object-specific. Instance members are intrinsically tied to a specific object that you create from a class. Think of them as personal attributes for each individual object. Unique copies. When you create multiple objects from the same class, each object gets its own distinct copy of these instance members in memory. Changes to one object's instance data don't affect another's. Access mechanism. To interact with an instance member, you must first create an object and then access the member using that object's reference. Example, myStudent.name. Real-world examples. The name of a student. Each student object has a unique name. A bank account balance. Your balance is different from your friend's balance. A car's color. Two cars of the same model can have different colors. Static members. What are they? Class-bound. Unlike instance members, static members belong to the class itself, not to any individual object. They represent attributes or behaviors shared across all instances of that class. Single shared copy. There's only one copy of a static member in memory, regardless of how many objects, or even one copy of the class, or all objects belong to all instances of the class are created. You declare a member as static by using the static keyword right before its type in the declaration. Example, static string college. Examples: a university main for all students studying there. A universal bank interest rate applicable to all accounts. The mathematical constant pi, math, pi, in Java's math class. Key differences. A quick comparison. Let's summarize the core distinctions between instance and static members with this comparison table. This will help solidify your understanding and provide a quick reference. Feature. Instance member. Static member. Ownership belongs to each object, belongs to the class. Memory allocation. Separate copy per object. Single copy, shared by all. Access. Through object reference, through class name or object. Example, student.name, student.college. Remember, the choice between instance and static directly impacts how data is stored, accessed, and behaves within your Java applications. Code example, the student class. To see these concepts in action, let's look at a simple student class. Pay close attention to how name and college are declared. Here, name is an instance variable, because every student has a unique name, while college is static, because all students in this context attend the same college. Main program, putting it together. Now, let's write the main method to create student objects and observe how the instance and static members behave when accessed and modified. Notice how we access the college static variable directly using the class name student.college, which is the recommended way, rather than an object reference. Program output. The proof. This is the output you'll get when you run the main program. See if you can predict what happens to the college name after we change it. The output clearly demonstrates the unique nature of instance variables and the shared behavior of static variables. Let's break this down further in the next slide. Explanation of output. Initial display. The first two lines show that both student objects, S1 and S2, initially share AJC as their college, as expected from a static variable. The change. When we execute student.college equals key_tu, when we are directly modifying the single shared copy of the static variable college that belongs to the student class. Post-change impact.
The subsequent two lines demonstrate that this single change to the static variable immediately affects all existing objects of the student class. Key takeaway: instance variables, like name, remain unique to each object, while static variables, like college, are truly shared, and a change to one affects all. Conclusion and real-world usage. Instance members for unique data. Use instance members when each object needs its own distinct set of data, like a person's name, a product's ID, or a bank account's balance. Static members for shared data. Opt for static members when the data is common or shared across all instances of a class, such as a college name, a universal interest rate, or a company name. Efficiency and clarity. Proper use of static and instance members leads to significant memory efficiency, avoiding redundant data copies, and ensures improved code clarity and maintainability. Best practice. Always use instance when data is inherently unique to an object, and static when it represents a shared attribute or a utility method belonging to the class itself.